My name is Diana Hooper, and I'm a postdoctoral researcher currently at the Helsinki Institute of Physics over at the University of Helsinki, obviously in Finland, where I get to study cosmology. That means that I study the universe, the contents of the universe, how everything evolves, how everything interacts, basically all of the fun things happening inside the universe. It's a great topic. I love studying cosmology. I love that I get paid to study the universe. I will never get over how cool that is. That, I just get paid to study all of the cool things happening outside in space and what's going on in the universe. It's great. It's really fun topics. Hey, David, great to see you in first. Still no HAPS notifications? Yeah, there's been a HAPS bug for like a month by now. I know some of you aren't getting the notifications. Hopefully, you can all find your way in anyway. So wherever you're watching from HAPS, if you're on Reddit, on Twitch, on Twitter, on YouTube, welcome. It's great to have you all here. So yeah, I'm a cosmologist. I study the universe. And I absolutely love studying the universe. And I really like coming on HAPS or whichever platform you're watching on and chatting to everyone about all of the wonders of the universe. Still no notification for you either, Scott? Yeah, I'm afraid that is a recurring issue. Hey, David Dunn, great to see you as well. Honestly, I think the safest way to get notifications is to subscribe to the YouTube channel. That's Cup of Cosmology over on YouTube, because those notifications do seem to be a bit more reliable than the HAPS notifications, unfortunately. But, wherever you're watching from, I'm glad you were able to get in, even if there were no notifications. So yeah, I like coming on HAPS or whichever platform you're watching on, answering any questions people have about the universe. Thank you for the log burst award, David. I do really appreciate all of the awards you send me. So I don't have a specific topic today. There's a few things I do want to talk about. If anyone was watching last week, I know I advertised a special guest today on the topic of general relativity. We've had to postpone that to a later date. That's perfectly fine, which means today is just going to be a general Ask Me Anything. I'm going to try to answer any questions you all have about the universe. There's a couple of things I want to briefly mention and chat about as well, but today really is open to anyone asking anything you like about the universe. Now, before we get into all of the fun science stuff, actually the YouTube ones are usually several minutes behind. That's interesting. Yeah, I know the Twitch ones are also like 7 minutes behind for some reason. I didn't know the YouTube ones were so delayed, but that explains why it takes people on YouTube a few minutes to come in. I hadn't realized. Obviously, I don't get my own notifications because I'm usually focusing on the chat. Exactly, David. The general relativity got time dilated. Time is messy. There's no such thing as an absolute time. So we were going to do general relativity this week. We're just going to do it some other time. It's fine. Hey, Paul, great to see you. You identified all the crosswalks in a picture for HAPS for the umpteenth time. Yeah, it's yeah. I know it's a bit difficult to find me on HAPS right now. I know the team is working on this, so I do really hope that this will be fixed soon. I know some of you are having issues with HAPS. I do apologize for that. Hopefully, you're still able to find me. At least I'm regular. Every week, same time. It's always easy to find me. Just if I'm not online, I usually advertise that I'm not online over on Twitter. So even if you don't get a notification, 8 p.m. my time on a Sunday, you know where to find me. So hopefully, even though no notifications go through, hopefully you're all still able to be here. I do see a lot of the regulars in here, which is nice. Hey, Dharma Phi, nice to see you as well. Off topic, but I saw a Morbius last night. Oh, nice. I saw Morbius. Yeah, I haven't seen that. I've heard about it, but I haven't seen it yet. It's on the list, but my watch list is ridiculously long. It will take me a while to get there. So before I get into science and physics and fun things like that, I just want to remind everyone of something which I find extremely fun, and I hope you all do as well, because I at least am having fun with it. So I want to go back to the Cup of Cosmology logo, which you can see up on your screens or whichever direction on whichever platform you're watching on. Now, this is the Cup of Cosmology logo, which debuted 2 months ago, just over 2 months ago, when we did the big relaunch of Cup of Cosmology, with the new webpage, cupofcosmology.com, the email address, contact@cupofcosmology.com. I launched this new logo designed by a very good friend of mine, Sania Hiva. Now, I'm bringing up the logo again because when I did the relaunch of Cup of Cosmology at the end of January, I advertised that there was an Easter egg in the logo. And people are sending in incredible guesses for the Easter egg, but nobody has found it yet. So I want to review what is and isn't an Easter egg in the logo, because a few of you keep finding things that are not Easter eggs. So let's review what's in the logo. First of all, from bottom to top, we have the CMB, the Cosmic Microwave Background Radiation. This is the most wonderful thing in the universe that people might have heard me mention once or twice. Sticking with the CMB, we have the ripples. These represent the gravitational waves. So we have CMB, we have gravitational waves. The idea here is the cup is scooping up a cup of the CMB and creating the universe in the process. On the logo, obviously, we have on the mug, we have Cup of Cosmology, which is the name of the show. There's also these kind of cracks you can see on the mug in a nice purple color. Those represent the large-scale structure of the universe, the cosmic web. Then inside the mug, we actually have the galaxies, we have stars, we have a blue dot which has canonically been accepted as a blue dwarf. We have wormholes. But there is one thing in the logo that nobody has found yet. Hey Abyss, great to see you. Haven't seen you in a while in the streams. Great to have you here. So people have come up with some really, really cool ideas about whether there's dark matter in the mug, whether the shape of the handle represents an omega, which we use for densities. Someone also asked me if there was a holography guess here, if it's topology related. All of those answers are really cool, but are incorrect. So there is still an Easter egg in the logo that nobody has found. I drop hints occasionally, and I'm going to drop another big hint and say that, so I've already advertised that the Easter egg is related to the shape of the mug, and it is related to something I have shown multiple times on my live streams. Let's see if that's enough for someone to figure it out. As always, if you have a guess for the Easter egg, DM me on Twitter or Cup of Cosmology, contact at cupofcosmology.com if you want to go the email route. If you do find the Easter egg, please don't reveal it publicly because let's keep everyone guessing. But do message me if you have guesses. I think I dropped a very big hint now, so good luck with that. I just wanted to do that at the beginning because I'm having a lot of fun with all of the guesses people are sending in. Okay, random physics question from David. Primordial black holes in the cup. There might be primordial black holes in the cup. There probably aren't. It is not the Easter egg. You have a guess, Scott? Please DM me on Twitter. Let's see if that's correct. So, random physics question, perhaps the safer or the relativity one. How does matter tell space to distort? If I created some matter, it would presumably start distorting space-time. Okay, so this is a great question. This is something we will also cover when we come back to general relativity. But in a nutshell, the universe gets curved by the presence of matter. So matter distorts space-time. Now, one analogy that we use often that is only useful up to a certain extent is to imagine that the universe or space-time is a big sheet, like a trampoline, or just a bed sheet with 4 people holding the edges. Now, if you put a bowling ball in the middle of your sheet, it's going to fall down and distort. Then if you put another smaller object, another smaller round object, it's going to fall towards where you have the big object in the middle. So space-time does something similar. If you have an object with mass, this is going to create a gravitational force, and it's going to kind of curve space-time. This curvature of space-time is what then creates a gravitational force. So what you're saying here, how does matter tell space to distort? It basically has mass, and this affects the curvature of space-time. So space-time curves around objects that have mass, and this causes objects to move. So if you create some matter spontaneously, it would immediately start distorting space-time. If you suddenly produce a black hole, which you can't just go click, black hole appears, but if you could, immediately this would start distorting space-time. Now, one cool thing is that the gravitational force propagates to the best of our knowledge at the speed of light. So if you create a big black hole here now, then it would take the effect of this, or the curvature of space-time would be felt kind of at the speed of light going outwards. So like if you suddenly created a black hole on the outskirts of the solar system, we wouldn't immediately feel its presence. It would take a certain time for us to feel this gravitational force. But as soon as you have an object with mass, you are going to create a curvature of space-time. I hope that answers the question. You never like the rubber sheet because it is gravity that makes the ball distort. Yeah. This is the very, very, very common argument, and it's the correct one, because we use the sheet as an analogy, like, yeah, the sheet curves, but the sheet only curves because of space-time, and because of gravity, and we're kind of using that to explain gravity. So that is exactly where the analogy breaks down, and it's one we always use, and whenever someone makes a comment, if you can't use gravity to explain gravity, it's like, yes, you are very correct with that. So the question of how exactly does matter curve space-time is not completely clear. It's just an object with mass curves space-time. It distorts space-time, and this produces time dilation, length contraction, all of the cool gravitational effects that we're used to. And if a really heavy person gets on a trampoline, the springs break. Depends on the trampoline. Some trampolines can manage. Every object in the universe has kind of a limit, right? So yeah, don't deliberately break trampolines. It's not pretty. But trampolines are so fun. I love trampolines and trampoline parks. But yeah, those questions about space and time are always really fun and really difficult to answer. I do hope that when we do a stream specifically on general relativity with an expert who's just written a book on the topic, we can address all of these questions in a lot more detail than I would want to go into by myself. So, as always, you can ask anything you like. I do believe we don't have a Reddit connection today. That's fine. So, as always, you can ask anything you like. I'll try to answer any questions you have. In the meantime, I'm going to talk about something that I'm really excited about. That is something that happened, that I've been involved in, and that was finally done this week. So, we have a problem when we study the universe, and that's that we can't put the universe in a box. You can't just go to your lab and build a baby universe and see what happens. We don't really have a reproducible universe that we can play about with. We are limited to one universe, which is the one we live in. And it's quite hard to do science when you live within the system, because any observation you make is going to be affected by the fact that you are part of the system that you are studying. Reddit is busy with our places. Yeah, that is true. That is true. I've never ventured into that. I know of it, but yeah, I'm gonna stay away from that. Just seems like chaos. So we always have the problem of how do we study the universe? And one way that we have to study the universe is to simulate it. So we take a computer code that simulates the entire history of evolution of the universe. It's based on all of our known laws of physics. And you give it some input, like my universe has this amount of dark matter, this amount of dark energy, and this is what I expect the universe to look like and behave like. You press play on the simulation, or you run the code, and it will simulate what the universe would look like. Now, it doesn't spit out a complete universe. What it spits out are what we call the main cosmological observables. And depending what type of simulation you're doing, you will get a different output. So, for an example, you've already heard very recently on the show about simulating phase transitions and gravitational waves in the early universe. Sounded like somebody just cracked open a beer or soda pop. Not on my side. You might hear some noise from my dishwasher, but hopefully not. So definitely no beers being drank here. Someday, maybe, I will do a cup of cosmology while drunk, because I know people like those things. I can also warn that if I do that, it will be absolute utter chaos and probably very funny for everyone. So maybe at some point we'll come back to that idea, but it's not in the plans right now. Anyway, I've talked a lot about how we simulate different parts of the universe. I've had guests on to explain how we simulate the early universe. Now, as people know, my favourite observation in the universe is the CMB, the cosmic microwave background radiation, which is the oldest light we have in the universe in any direction we look. It really is the background radiation, the afterglow of the Big Bang itself, and somehow the image is not coming up. Why is the image not coming up? This is not going to plan. Why? There's my image. Let's see. I've got my image up. Everyone knows that it's a crisis if this image doesn't appear. CMB, cosmic microwave background radiation. Yes, David, I was able to get it up. Don't worry. Crisis averted. Oldest light we can see in the universe in any direction we look, kind of the afterglow of the Big Bang, and it really gives us the statistical properties of the early universe. Now, when we want to study the CMB, we don't just focus on the red dot or the orange dots. What we do is we kind of take the fingerprint of this universe. So we take the statistical properties of the CMB. And if we do that, the thing we get, let me just see if I can find my other image. The old system was much nicer for presenting on screen. Okay, so what we do is we take kind of the fingerprint of the CMB and we get the statistical properties which are encoded in this new image, this graph here. What you can see here basically is the size of the blobs that we're looking at and the amount of different blobs that we have. So how many hot spots and cold spots we have of a different size. What you can see here in the red dots are our best data from the Planck mission coming from the image of the CMB I showed. And what you can see in the green line is our best prediction to reproduce this data. The left end looks a bit wonky. Yes, the reason for this is going back to what I was saying just now. that we have the big problem that we only have one universe. Now, if you look here, what you can see on the bottom axis is the angular scale. So this is the size of the patch we're considering in the sky. The further to the right you go, the smaller the patch in the sky that you're looking at. But the further to the left you go in this figure, the bigger the patch. And if you take 90-degree chunk in the sky, there's only 4 of them you can take. That's not a lot to do statistics on. Whereas, on the other hand, if you take half a degree of the sky, there's hundreds of those that you can take. Because we only have one universe, we only have one CMB, we only have one study that we can do, which means when you try to take these big angular scales, like 90-degree angles on the sky, you are very much limited by the fact that we cannot do systematics with so much. So this is exactly why the error bars on the left are substantially higher. It's because we really don't have enough statistics on these scales. This is what we call cosmic variance. And you can produce the best satellite ever. You will not be able to reduce the cosmic variance by much, because this is just limited by the fact that, we don't have more than one universe. And because we are limited to one universe, we can only take 4 or 5 chunks on the sky of specific sizes, which really does limit the amount of statistics we have. So this is why the error bars are bigger on the left and smaller on the right. The spread of green is the predicted error bar size. Yeah, so the red error bars are from the data itself. So the red error bars are really the spread of the data. The green band that you can see is our prediction given what we know of cosmic variance, given that we're limited to one universe. So what this means is that basically on these small scales, it could be anywhere in that green band. And then we have the very nice prediction. So this is the prediction that currently is given by lambda CDM, which is our standard model of cosmology, which means the universe is made up of dark energy, dark matter, and normal matter. 68% dark energy, 26% dark matter, 5% normal matter. This is what we get from this pretty picture that we have up here. And I know I missed a couple of comments, so let me just go back to those. Okay, there was one by Paul that I will come back to later because it's slightly off topic, but that's fine, I'll come back to that. Spread of the green, yes, so the average spacing between cooler and warmer areas is 1 degree. Kind of, yes. Yes, basically that is, or one way of phrasing is like that is where there is the most temperature differences, or the most statistically significant places where you get the anisotropies in the sky, these hot and warm spots. So yeah, the 1 degree separation is kind of not so much the average, but it's where you get the most information from. But you could not really the most information either, sorry. Yeah, the average spacing between cool and warmer areas is 1 degree. I would say yes, that is the correct interpretation, yes. Okay, so this is one of the main cosmological observables, but what I'm showing you here is only one part of what we get from the CMB. So this is what we call the temperature anisotropies, and this is the hot spots and cold spots of the CMB. But from the CMB, we also get a polarization map, which shows us in which direction the photons are vibrating, and we get the link between the two. So we end up with and we get a lensing map. So from the CMB, we actually get 4 of these graphs, not just one. And with this, we can do a lot of statistics. We can learn a lot about the early universe. So why am I talking about all this? Because we had this green line, which I say is the prediction from lambda CDM from our current cosmological model. This is a very odd tea. I have not tried this tea before. It is green tea with strawberry and cucumber, and in the hindsight, I should not have got something that's such an odd combination. Who puts cucumber in tea? Who buys tea with cucumber in it? Apparently I do. That is weird. Okay, sorry for that tangent now that I've discovered my tea is slightly weirdly tasting. So I showed you that we have this very nice green line, which I said is the prediction that we have from lambda CDM. So I'm noticing a slight lag on my video. Please let me know if the video is working for everyone watching. Hopefully there's no issues there. Cucumber goes in gin. I'm not a gin drinker myself, but yeah, if you say so. I'm not cucumber in gin. Really, that just sounds odd. But I'm not a gin drinker, so maybe you're right. Okay, so I showed you that we have this nice green line, which is the prediction. Video smooth, perfect. Thank you, Paul. So how do we get this prediction? And this goes back to what I was saying about simulating the universe. So there are several existing codes on the market that simulate the evolution of the universe. There are mainly two that people use. There is CAM, which is written in Fortran, and there is class, which is written in C. Both of them have a Python wrapper. This is a very broad question. Do quantum physics find similar problems as cosmology with math? I will come back to that question. That is a nice question. I will come back to that. So, stop putting cucumber in beverages. Yes, thank you, Scott. Why is there cucumber in my tea? No idea. Why did I buy it? No, there was cucumber in it. No idea. It's just weird. So, yeah, two main cosmology codes on the market currently: CAM in Fortran, class in C. They both have Python wrappers, so you can interface them with Python. It's very cool. And what these codes do is they take your input model, your input cosmology, and they simulate the evolution of the universe, and they spit out a CMB. Not the map itself, but this spectrum, this green line that we saw. And what we do to get this perfect green line is we run the simulation like a million times, and we figure out which of the simulations we ran best fits the data. And this gives us our best fitting. Cucumber actually sounds interesting. May try it. It is a hot tea. It is green tea with strawberry and cucumber. And I don't know why I bought it. I was curious, but apparently this is a thing that people like. I am not one of these people, and now I have a whole box of this. I might just leave this next to the tea machine in the office, and anyone else can help themselves to this very interesting tea. Keep getting distracted by my tea now. You have to rename the show to Cup of Tea and Cosmology. So, yeah, drunk cosmologist drinking game. Get 4 cosmologists on a broadcast and everyone has to drink anytime CMB is mentioned. Now, I feel like I would lose that game immediately. That is a clear way just to get me drunk. Or better yet, everyone takes a shot anytime Deanna mentions the CMB. Then everyone's going to get drunk. Plus the frozen ocean and now cucumber tea. Yeah, I am very easily led astray. It is very easy to throw me off topic and get me rambling about random shit. But, then you will know my tea preferences. I have a billion questions about coding because it's my expertise. Awesome. I love coding questions. And this is actually, I know I'm rambling a lot today, but there is a point to all of this. So, since I started my master's, actually, I have been involved in modifying and developing the class code. So I've added several modifications. I wrote the documentation for the code. The reason I got into class and not CAM, for one, is CAM is in Fortran, but also because my PhD advisor was, and still is, the main developer of class. So I kind of just by extension got into class. So I've been involved in a lot of the coding of class over the last 7 years. Oh God, that feels like a long time. Wow. Okay, so that's a nice realization. So yeah, I've been involved in class coding, class development for the last 7 years, apparently. Wow, God, I feel old. I've had contributions to some of the major releases. I've had minor contributions. But there's one thing that I had been working on since my PhD days, which this specific project started in 2017. And that is, Deanna has a lot of class. Thank you for that, David. I love that pun. I'm just going with it. So, yeah. One of the biggest projects I've been involved in coding-wise is adding new things to class in terms of dark matter. Now, I mentioned before, lambda CDM means dark energy, and the CDM part means cold dark matter. What we mean by cold dark matter is matter that does not interact with anything else. It means it doesn't bump into other species. So we know that within the standard model of particle physics, like protons will smash into electrons talk to photons. There's a lot of interactions between different particles. But in our standard model of cosmology, dark matter does not interact with anything. Dark matter is there doing its own thing. Now, one of the series of projects that I've worked on is asking the question of what would the universe look like if dark matter actually had interactions. If dark matter could bump into photons slightly or bump into baryons, which are just like protons in the early universe, what would happen? What would happen if dark matter could bump very slightly into a hydrogen atom in the very early universe? What would happen if dark matter could do photons and protons simultaneously? And what if we throw in a relativistic component to the dark matter? So we have dark matter and dark radiation, which is basically like dark light. What would happen if dark matter and dark radiation speak to each other? Put out several papers asking these questions. But in order to answer these questions, one thing we need to do is add these interactions to one of the cosmology codes. In my case, to class. So one of the biggest goals of my PhD, apart from answering these questions, was actually getting a version of class, a public version of class, with all of these interactions there for anyone to use. So that if anyone else wants to ask the question of what happens if dark matter and photons behave like this and talk to each other, there's a code for that. This is something that I've been working on since 2017. Not alone, there have been two other main developers involved, two other people who have really helped push this. One of them was a PhD student in Aachen, is now a postdoc in Barcelona. The other was a master student in Aachen, is now somewhere in Germany doing his PhD. So this has been a huge amount of effort. And this week on Tuesday, so 5 days ago, we actually made this code public. And I'm really excited about this because this is one of my biggest coding projects. And it's now part of the main version of class. So anyone who downloads class, the public code class, now has the option of just switching on with one line of code. You don't even need to modify the code, just with the input file. People can now say, make my dark matter talk to photons, make my dark matter talk to baryons, make it talk to dark radiation, or all three at the same time, or any combination of these. And this is now in public class, which closes a big chunk of my coding project. This was a huge project. I condense everything into like one final, we use Git, which is just a way of keeping control of the code and every change. And I condense all of it into one commit, one like checkpoint. And when I did that, it gives me a complete summary of the changes. This coding project involved adding 3,600 lines of code, removing 2,500 lines of code. 5 years of effort involving me and two other people. I was on it for 5 years, the others were on it for 3 and 1 year. But it's done. It's now out there. It's now part of main class. This is really cool. And I'm really happy about this because this is something I've worked really hard on. And I know most of you will never ever use class in your life, but I just wanted to advertise the fact that this is out there now. Let's see, I know I ignored a couple of questions there. There was a comment from Abyss. Is that class as in OOP class, right? You keep saying class, which confused me a bit into thinking it might be the name of the package. Yeah. So class is kind of a wordplay. So the code is called class, which is an acronym because physicists do things like that. We're very, very, very bad with acronyms. Class stands for Cosmic Linear Anisotropy Solving System, class for short. So Cosmic Linear Anisotropy Solving System. That means that we solve the anisotropies of the universe using linear physics. So Cosmic Linear Anisotropy Solving System. And it's also a play on words because even though it's written in C, it uses a lot of the C++ class structures. So it's very object-oriented. So we do use kind of classes as the main framework within the code. So it's kind of a double meaning there, that it's class for the cosmic linear anisotropy system, and it's a wordplay on the fact that we do use classes. So yeah, if the software says dark matter can interact, then it must interact. Well, unfortunately, what would you need to observe in the real world to see if dark matter reacts? Thank you for both of those questions. So the code actually says what happens if dark matter interacts. Let's test it. The data tells us that actually dark matter probably doesn't interact. So what would happen if dark matter, for an example, bumped into photons? What we would see is a difference in the CMB. So those peaks would be slightly different. So what this means is that we can put upper limits on how much they could interact. We can say, based on the CMB, we know that if dark matter and photons interacted, their strength, or what we call the coupling between the two, which just tells you how likely they are to bump into each other, has to be smaller than this specific number. Because if it's larger, we would have effects on the CMB. So it's very difficult to find something that we say, haha, look, here's something that we can point to that is definitely happening. What we can say is, if these interactions happen, they cannot be larger than this specific amount. However, on that note, would dark matter react to larger mass more than smaller due to obvious gravitational effects? If you're only looking at gravitational interactions, yes, but the type of interactions we're looking at here would not be gravitational. what we're assuming here is that there is another type of force that provides this interaction. In case of dark matter interacting with photons, for example, which are particles of light, we're basically looking at dark matter that has a very, 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 very small electric charge. So then it's interacting via the electromagnetic force very, 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 very weakly, if at all. So these are the type of questions we can ask. Now, within the CMB, we do not find any hints for any interactions. Lambda CDM is always a better fit to the data. If we look at Lyman alpha data, that is not completely the case. I did a whole episode about that where I brought on a co-author of mine where we talked about the possibility of dark matter interacting with neutrinos and what Lyman alpha data tell us about that. And I'm going to leave this open as an open point because I'm going to come back to that when we put out another paper very soon. Exciting. I'm just going to leave that hanging. But from the CMB, we do not find any evidence of dark matter interacting, at least in the models that I've looked at. But the cool thing is this is now out publicly. So if anyone else wants to ask this question, everyone is welcome to do so. You just have to go and download the code. On that note, I just want to do a very quick screen share, if I can. Screen share on incoming. Let's see, with this one here, I hope you can see the screen coming up. Yes. So what you can see here is the actual class code. So this is the web page for class. I know you can see the web page here at the top. The cosmic linear anisotropy solving system. This is where you can get all of the latest versions. If you do a search for class code, you'll find it. And here's instructions for download. Here's the documentation. I mentioned here that I wrote the documentation, which is very nice. And if we go down to version history, we now have version 3.2, implementation of multi-interacting dark matter, credited to me and the other two people who helped with this. So yeah, it's out there, it's public. I know I'm just doing a bit of self-promotion here, but I was really, really happy to get this out. It's been a huge amount of work. So I'm just very happy to share that with people. You've seen the Git page, yes. To answer your question, Abyss, I know there was another question you asked. Where was it? Is it scalable? Can you use it on scalable compute grid? So class itself, thank you for the love celebration award, David. I really do appreciate that. So class itself is scalable up to about 12 cores. After that, it doesn't scale well. So usually you want to run it, if you can, you run it on 12 processors. But the good thing is that usually when you call class, it's via a code that's comparing it to the data if you want to run class like 100 times. Thank you for the love burst of word of this. I really do appreciate all the awards. And then the other codes are scalable as well and can be parallelized. So class is parallelized and it scales up till about 12 cores to my knowledge. I think you can push it to 16, but it stops scaling well. It scales well up to about 12 cores. I don't know why I'm still drinking this. I've already decided I don't like it, but it's a thing. If you have a drink that's open and next to you, you're just going to keep drinking it. Thank you for the heart bomb award, Scott. I'm going to have to hide my tea mug from myself because I keep drinking that nasty cucumber tea. Who puts cucumber in tea? Seriously. Okay, so I know that was a long tangent. I just wanted to... I get the question often of what do you spend your time on? And what I spend my time on is apparently developing these codes and obviously a lot of other things. But this has been a huge chunk of my life. And yeah, it's done. It's finished. It's wrapped up. And I was so happy on Tuesday when we got that out. I basically put the code out Tuesday afternoon and then was like, I'm not doing any more work today. I am done. So yeah, I'm very happy about that. So I know that was like completely on a tangent, just talking about coding, but it's something that I was happy about and wanted to share with everyone. And I know there were some questions on different topics that I wanted to come back to. Makes sense how your modules are organized. Some can be parallelized, some can't, exactly. So without going into too many details, for example, when you calculate the thermal history of the universe, that kind of needs to be done in order. But there are some things like simulating the perturbations, which is just that is how you actually do the full evolution of the equations that can be split up and doesn't need to know knowledge of what came before. So some of it can be parallelized, some of it can't be. And depending on the type of model you run it through the parallelized part or the not parallelized part. So it very much depends on what you run. As you say, it's a very modular code. Some modules are parallelized, some are not. So I know there were a couple of questions that were not related to coding and I ignored them because I wanted to come back to them. So let's come back to them. There's a question by James. This is a broad question. Do quantum physics find similar problems as cosmology with math? Now, the thing about quantum physics is it comes with its own batch of problems. Now, mostly, the mathematics of quantum physics is pretty understood. Things get messy if you try to add the gravitational force into quantum physics, because then things make no sense. We have no idea how to do that. So, can atomic weight be off due to dark matter? Probably not. Now, dark matter is something that we only know about because of the gravitational force, because of its gravitational impact on other things. And here's the problem. As I was just saying, we do not know how to fit quantum mechanics and gravity together. So we don't know how these things actually fit together. It's very difficult to explain how gravity behaves on the quantum level. The reason is that gravity is the force that we know on big scales, on large scales. When you go down to small scales, it becomes very messy. So does dark matter affect the measurement, the position of particles? Maybe. But to understand how, we would need to know how the gravitational force behaves on the quantum level, and we don't. So to answer your question, James, quantum mechanics does not suffer from dark matter problems, but we don't really know how to fit gravity and therefore all of the effects we attribute to dark matter into the quantum world. So it's a whole mathematical problem. If you come up with a solution, please do write it up, publish it, because you have a theory of quantum gravity. First one to get a complete theory of quantum gravity might get a Nobel Prize, probably will. So, do come up with ideas. Do let me know if you have ideas for how to put gravity into the quantum world, because we're out of we're not out of ideas. There's a lot of people working on that. Hey, Chris, great to see you. Last week's guest is in the comments. Chris, great to see you. Thank you for joining. If anyone missed last week's episode, you should watch it. It was great fun. And make sure you follow Chris Patterson on YouTube for cool videos. I believe there's one involving lasers coming out soon. Today, I believe it was advertised. So do check that out. Message from Scott. I've probably written tens of thousands of lines of code at my job over the past 18 years. Yeah. Sometimes I think that's a cool thing, that I get to contribute to codes that are open source and publicly available, because then you can really feel like you're actually contributing to a code. As someone who worked on a code for nearly 5 years, I know the blood and sweat going into it. Thank you, Abyss. Thank you for your comment. Yeah, I just wanted to advertise that because of just how much work it's been from my side and from everyone involved. Okay, and I know there was another comment quite far away. I think it was from Paul, just before I started on the code, which I ignored. So let's see if I can scroll all the way back and find that comment. Where was it? Is there uncertainty telling the difference between distant objects that are redshifted because they are moving away from us versus light emitted by distant objects which stretches into longer wavelengths as it travels because the universe is expanding? So that's an interesting question. So yeah, I think if you look at an object for long enough, like with long exposure, you can get a pretty good idea whether it's moving away from us or moving towards us. So yeah, I think you let me just reread your question to make sure I'm answering that properly. The difference between objects that are redshifted because they're moving away versus objects with wavelength stretch. Yeah, I think it just comes down to how long you observe an object. We're pretty good at telling when an object is moving away from us by the way its spectrum changes. So what we do is we take like a spectral decomposition, which is just making a prism come out of the object and looking at where we have specific lines and matching them up to different benchmarks, and then we can see that an object is moving away from us. So usually we can tell, but there also is this thing that pretty much everything in the universe is moving away from us because of the expansion of the universe. So you have kind of two velocities to deal with here. We have the velocity caused by the expansion of the universe, and we have the recession velocity, which is an object moving on its own accord. But most of the things that we know that are moving away from us is generally because of the expansion rate of the universe. But of course, there are some things that just happen to be moving away from us. But I think we can. I think that does answer your question. If not, as always, please do let me know. If there's something that I say that is unclear, if there's something I say that you disagree with, please do let me know, and we can come back to this. Does the code predict the universe? Okay, yeah, I see that's not for me. Usually if a comment starts with someone else's name, I don't read it. Sorry, but I just saw something about NASA and got distracted. But yeah, as always, if something I say is not clear, please do ask me and I will try to clarify it. It is actually starting to grow on me. It's cold by now. Maybe that's the trick, to just let it get cold. I just hear it's a mug with a drink. I'm going to drink it. Odd academia questions. I love questions about academia. This is a good way to get me to rant. Would a paper you submit be considered a published work as required by universities? Nice question. So, depends what you mean by submit, where we submit the paper. I know I use the phrase sometimes if we submitted a paper. Now, there are several different stages involved. Now, usually, the publishing picture is you submit a paper to a journal. The journal sends it out to 1, 2, or 3 referees who are just peers. They're basically someone else working on the same topic. There's some peer review. In ideal cases, it's constructive feedback. You go back and forth a bit with constructive comments from the referee, and you converge on a version of the paper that everyone is happy with. It's passed peer review. The journal publishes it, and then it appears in the journal. The problem is, without going on a rant about publishing and referees and how constructive criticism is not always constructive and is often just criticism, let's shelve that rant. The problem is this peer review process can take a long time, and usually you want to share your results immediately. So there is actually a server that we use within the community, which is called Archive. It's ARXIV. And this is where we put what we call preprints. So this is where you already submit a paper pre-publication. So usually what we do, what a lot of people do, is you put the paper on the archive. If I put a paper on the archive today, it will appear Tuesday morning. So this is quite a quick process. And you need to be verified by at least one person on archive. Like the first time you submit to archive, someone needs to kind of loop you in, but then you can submit papers. Every day we get a list of all of the new papers that have been submitted. You can check it, you can subscribe to it, you can get it in your email. Now, we know that anything on the archive, when it initially appears, has not yet passed peer review, but it is a way to already share your results with people. And often we'll put papers on the archive and then wait about a week before submitting to a journal. This depends very much on the individual person. This is what I've done in my experience. You put it on the archive, you wait about a week. This week gives you time to already get a first batch of comments from the community. You know, if the day after it appears on the archive, someone emails you like, your paper is wrong, you might consider not submitting it to a journal if they're correct with what they're saying. What usually happens is you get emails from people saying, hey, I worked on something similar, you didn't cite me, it would be nice if you included a citation. So then you might make small changes, crowdsource kind of peer review, and then you submit it to a journal. The journal will send it out to editors. You do the back and forth with the revisions, and then eventually it gets published, hopefully. Unless it's a really bad paper, then it might get rejected. So, or if, yeah, it might get rejected without being a bad paper because of reasons that I'm not going to go into, but this is the perfect case, and academia is far from the perfect case. I'm doing my best to not go on a rant here, but this is absolutely going to end up in a rant, I know this. So, yeah, this peer review process can take a couple months, and what usually happens is once it's approved for the journal, you update the archive version with like, this is the version, you put a comment like matches published version. So then there is the open access version, because everything on the archive is completely open access. You have the open access version that is not kind of journal approved, and then you have the version in the journal, which is usually behind a paywall. The fun thing is, okay, here we go. I know this is going. The fun thing is, you might have all seen a paywall when you try to access a scientific paper, and I've had people ask me before, how much do I get if people pay to go see my papers through the paywall? Nothing. None of that money goes to the authors. Absolutely none. If you pay a journal to read a paper, that goes all to the journal. None of it goes to the authors. It's just the way the system works. Also, the editors, the people who referee the paper, also often don't get paid, but that's a whole other thing. So I went on a few tangents there, but let's go back to the question. Would a paper you submit be considered published? So usually when we talk about submitting a paper, what we mean is we put it on the archive. And if I say we published a paper, then it means it's actually in a journal. I think I saw an episode of Big Bang Theory about that process, lots of hard exchanges, editors and authors. Yeah, I'm just going to make a broad comment here that 90% of what's in the Big Bang Theory is absolute bullshit. I would not use that as a reference for what science is and isn't like. It is, however, a good reference for sexism, because that show is so full of quirky, misogynistic assholes. Anyway, I know a lot of people enjoy the show, and I don't mean to take away from that, so do enjoy it if you do. Do you own the intellectual property in your paper? Yes. Technically, yes. It depends on the license you use, and some journals might disagree with that, but technically, yes. Actually, I think somewhere, I'm not even sure now, but I think there's something to do with if the university where you wrote it owns some of the paper. You can see we don't really care about this. The thing is, if someone emails me and asks me for a copy of any of my papers, you will get it in your inbox. I will probably actually just link you to the archive version. All of my papers are on the archive, every single one of them. If anyone emails me and asks me for a paper, I will link, or any of my papers, I will link to the archive version. So if you're ever trying to access one of my papers and you get hit by a paywall, just let me know. Because, I wrote the paper, I want people to read it. And paywalls are not good for science. I think journals should be completely open access and the peer review system should be much improved. And this could be a whole episode where I rant about this, and I know a lot of people in academia who would happily rant about this topic with me as well. But yeah, I can send out a PDF of my paper if I choose to do so. And I'm always happy to do that. Here's my experience with publication, haha. Write the first draft, get an earful from your PI about how you should reconsider why you do research in the first place. Oh, that is not nice if there's PI who do that are nasty. Work on it for 100 iterations. Once you're confident enough, send it to a prestigious journal, get rejected, send it to a mediocre journal. Yeah. There's a lot wrong with the peer review process. Sometimes it works, sometimes it doesn't. If your PI, if your principal investigator made those comments, that's an asshole. Academia is full of them, but there's also a lot of nice people in academia. I complain a lot about academia, but there are some really nice people. There are some amazing supervisors, like my current supervisor. There are some really, really good people in academia. So there are some assholes that make a lot of noise and get a lot of attention, but there are some good people. Like patterns and human nature, scientists may fear submitting paper for fear of being stolen with modifications. I have honestly heard of things like this happening, but not so much. Like once you submit to a journal, it's very unlikely that someone's going to steal your idea. Also, once you put it on the archive, it's very difficult for someone to kind of steal your idea. And I have heard of things of like private communication among scientists where a student might email a supervisor like, hey, I have this idea. The supervisor doesn't say anything and a few months later publishes it as their own. I've heard of stories of this happening to people. It is a problem, but usually once you submit to a journal or put it on the archive, it's quite difficult. And in fact, it can happen sometimes that you're working on a paper and you hear that someone else is working on the same topic and is very close to finishing. And at that point, it might be that you publish or you put it on the archive a bit earlier than you were planning just to make sure that it's out before the other team does it. I know people who do this. In an ideal scenario, you just talk to them, coordinate, and put them out on the same day. That also happens. That has happened to quite a few people I know, where you just email someone like, hey, I think you're about to publish this, so am I. Let's coordinate. Let's not be assholes to each other. Sometimes it works, sometimes it doesn't. Humans in general love to flex their positions and power over others. Oh, there's a whole rant I could do about that, Scott, about privilege and people who have privilege. Obviously, I myself have a lot of privilege. I know that. But yeah, people in power. Yeah, let's not go there. You're given discouraging remarks by your PI. I'm very sorry to hear that, Abyss. I know how much that can hurt. I hope that people realize that when they're supervising others, their comments are more impactful than people realize. And I know that sometimes it's easy to make a flippant comment and never think about it again, but the person to whom you made that comment will be thinking about it. So I'm sorry that you went through that, Abyss. There's a lot of bad supervisors out there. One thing that is really interesting is that the further you... Someone James asked me about academia. Now we're off. There's no coming back now. I will need to reach out to you before I submit my quantum gravity solved paper. Yes, please do. Please do. I promise I will not scoop you. If you send me a paper of quantum gravity and it's a valid solution, I promise I will not scoop you. So, yeah. I was about to go on a rant and managed to just distract myself from going on a rant. Yeah, I remember what I was about to rant about. So, one interesting thing about academia, and I know this happens in a lot of jobs outside of academia as well, is that we're not actually trained to be supervisors. In many cases, we're not trained to be teachers. Yet, as we progress more and more in our career, we're expected to take on more teaching duties, more supervising duties, more kind of community duties, which makes a lot of sense and which we should do. And I will always advocate that teaching should be an integral part of doing research, and supervising is an integral part of doing research. But these skills are ones that we're not trained in. We're trained in problem solving. We're trained in picking up a textbook and reading it. We're not trained in supervising people. A lot of places will offer optional courses. Like, I know here at Helsinki there are pedagogy courses on how to be a good teacher, which is amazing. They're optional. And this is the thing that throughout my career, I've seen both good and bad supervisors. I've seen both good and bad teachers. And it's very interesting because these are skills that perhaps we should be trained in a bit more, given how much time we're expected to spend on these skills, on these parts of being a scientist. And some people think being a scientist is just my own research, and that's, in my opinion, not how science should work. Teaching is a vital part of what we do. Honestly, I think outreach is a vital part of what we do. Supervising all of this and research, all of this goes in together into being a good scientist, and it's things that we're not trained on as much as we should be. We're also not trained on how to write referee reports. Some people find extra training. I've been to workshops on how to write good referee reports. And usually my idea there is just imagine if you were receiving this referee report, would you be happy with it? If not, don't write it. There's always polite ways of doing things. A supervisor should be a mentor, yes. No such thing as a bad student, only a bad teacher. Yes and yes. I agree with you. Not in academia, but part of why I'm switching jobs is because my boss, aside from never telling me good job, calls me, yeah. If your boss is insulting you, that is a bad boss. You know, my biggest advice here is just join a bloody union. Everyone should join a union. Hopefully a union would help. But yeah, if your boss is criticizing you, if a supervisor is insulting you, a boss is insulting you, that's toxic. I hope people can get out of those situations. Note to self, submit academia questions only 55 minutes into the show. Haha, yes. I do appreciate your question, James, because as you can see, there's a lot of things I could rant about and a lot of things that I could go off on tangents on. I do like questions about academia, though, because, you know, academia is this like weird ivory tower that most of people have no idea how it works. Even the people inside are not really sure on how it works. So there's a lot. I think there's a big barrier in understanding between what happens inside academia and outside academia. So I do appreciate all questions about academia because I hope one of the things I hope to do with these streams is to shed light on the whole scientific process, not just on what we do in research, but, you know, how we do the research, how we develop these codes, how we deal with academia, how we deal with peer review, with mentoring, with supervising. So all of these are valid questions, and I know I just went on a lot of small rants together, and all of them are ones that I could elaborate on, and someday maybe I will. Someday. I'm a union branch rep. Awesome. Everyone should join if you can. Yes, absolutely. Go do that. Join unions. You know, it's time for workers to seize back the power. And before we go down that political discussion, something that generally happened to me was that a member in our group took my code and didn't even acknowledge my contribution. Yeah, that is shitty of them. I'm sorry. There's no good way of phrasing that. I know a lot of people are competitive and a lot of people will try to do what they can to get ahead. And honestly, what's the point? What's the point of getting ahead if you're trampling on others? Like, what's the point if we're not doing this as a community effort? But yeah, there are people like that, and I'm sorry that you went through that abyss. It's just really no nice way of doing that. You know, people have a choice. People can choose to be good or not, and as a good place tells us, it's important to every day try to be a better version of yourself. It doesn't matter if every action you take is good or bad. It just matters that you continuously try to be a better version of yourself. Okay, in the same as good or bad supervisor issues is just true outside academia. Yes, absolutely. A lot of the things we complain about in academia are basically just complaints about jobs. You know, I know outside of academia there are also good bosses and bad bosses. There are good mentors and bad mentors. There are people who know how to do their jobs. There are bad people everywhere. There are good people everywhere. I know this is not just academia. And often people in academia in our own bubble like to think that we have problems that no one else has. A lot of the problems in academia are just problems with, you know, people in general. So we don't have any kind of special privilege over, oh, we have different problems. We just have academia issues, but they're also just issues with jobs in general. But yeah, I do appreciate the questions. I remember not to pick up my tea this time. That's forgotten by now. So yeah, I do appreciate questions about academia, and I know I just touched on a lot of topics. If there's any of this that you want me to talk about in depth, I am happy to do so. With some caveats, as you know, I do still need to be careful with what I say sometimes. Sometimes I forget that, but I do still need to watch my words sometimes because I am still part of the system and I am still in a position where I don't have a permanent position. So these are things that I need to consider when I talk about these topics. But still, I do appreciate the question. I think I covered all of the questions. I know there were a few just before we went off onto an academia topic. I do like the odd academia topic that prompted this discussion. I think I covered all of the questions up until that point, so that's nice. Here are some comments about what nice. So there's a link here by Paul for what kind of culture to want to work in. Very nice. So there's a link there. Go read it. There's a lot of nice information out there about what makes a good and bad workplace. I was watching a TED talk about it recently. It's really cool. I've gone back to getting absorbed in TED talks for long periods of time, which is always very fun to do. Okay, so yeah, I didn't have a topic today. I've rambled a lot about CMB codes. Today's broadcast is more like cup of commiserations. Yeah, you know, ranting is good for your soul. Complaining is good for you. It gets it all out of your system. And honestly, I could go on a lot longer rants than what I did go on today. Are we doing GR next week? Probably not. I don't know when the GR stream will be. Once I know, I will advertise it. I will announce it on Twitter. I currently don't have a date. It will be rescheduled. That's all I can say for now. I'm honestly not sure if I will be doing a stream next week because I'm traveling back to Germany to see my partner, and I'm not sure if I'll be online next weekend. I probably will be, but I'll if I don't say anything, let's assume that I'm on. If I'm not going to be online on Sunday, I will cancel it at the latest on Saturday on my Twitter. So there's a small chance I won't be on next weekend. We'll see. I have to figure it out. New update shows links in blue but doesn't allow clicking. Well, at least it's showing links in blue now. I guess that's progress. I know Haps is buggy. We know that. I do believe they are going to fix everything at some point. It's just time and patience. It's always a thing. Time and patience and problems sometimes get sorted. Otherwise, complain about problems until they do get sorted. That's also a good life lesson. Okay, so I know I rambled a lot today. We talked about some fun things. We talked a bit about quantum gravity briefly, and I told you all about my code release, which I was super happy about. I'm just really glad to share that with you. And as always, if you want to know more about these codes, you can ask me. You can ask me about these codes. You can reach out to me always about these codes, about anything. If you want more academia rants, you can always ask me. I'm easiest to reach via Twitter DMs. My DMs are open to everyone on Twitter. Sometimes I do regret that, but most of the time it's good people messaging me. And you can also message me at contact@cupofcosmology.com. I know I still have a few emails there to respond to, but to everyone who emails me at contact@cupofcosmology just for feedback, I hope you know I really appreciate you because it means a lot to get direct feedback from everyone. Probably been a while since you've seen your partner. Yeah, long distance. It is what it is. But going there next week, so all's good. So as always, feel free to reach out if you have any questions. If you want to learn more about the codes that I've worked on, I think I put out a Twitter thread about the code as well. Thanks again for the rant. Yeah, always easy to get me to rant. What language do you think in? Good question. So I speak four and a bit languages. I would say I think in a combination, mostly in English, but if I'm talking to people in German, I will try to think already in German rather than think in English and then translate it because it's easier. And if I'm back in Spain, I will actually switch to thinking mostly in Catalan because then it's just more natural for where I am. But most of the time I think in English. I think in Python. Yeah, the amount of times that I've woken up from dreams where I was coding or stuck on problems, like that is a point when I think, whoa, I need a break. When I start having nightmares about my codes not working, which has actually happened, or at some point I start writing to-do lists and thinking this would be so much easier to write in Python. On that note, I've decided that the next update to my CV is going to be writing a Python script that automatically generates my CV for me. Because I don't have enough things to do. So, I don't think in Python most of the time. But yeah, it does have that effect on your brain sometimes. it's fun. It's fun. At least it's not Java. Oh God, yes. Ugh. I've had like one interaction with Java in my life, and it was like, oh God, no, thank you. This is not for me. I'll stick to Python and C. Those I can manage, and fun things like that, but not Fortran, not Java. No. Happy not HTML. God, no. Anyway, another thing I can easily rant about. There's a lot of things I can rant about. So, thank you everyone for joining and for allowing me to rant. I know you can just you can't really stop me from ranting. Thank you for the log burst word, David. I really do appreciate all of your words. So I should be online next week, hopefully. Maybe not, but probably should be online. And once I have a date for the general relativity stream, I will let you know. But yeah, I should be online next week. As I said, feel free to reach out to me either on Twitter or contact@cupofcosmology.com for basically anything. And thank you everyone for the comments. It's been super fun. I came on without really a topic prepared, and there's been enough comments and questions and random topics that we kept it going for 1 hour. So thank you for that. So I hope to see you all very soon. And I hope in the meantime you all stay safe and take care of each other.